Thanks for mathing with me today. In this video, we're going to be talking about function notation. Function notation looks like this. We have a statement that says f of x, and it's equal to y. So we say f of x equals y. F is the function's name, x is our input or domain, and y is our output or range. We can call functions by many different names, such as d of x, h of x, g of x, k of x. F is the most common. Functions are helpful to be named so that we can evaluate using function notation. This is helpful because if we want to evaluate a given function for many different values, which we will do in a moment, it allows us to see which value we're evaluating for. And this is helpful when we want to plot points on a graph. So if we were to graph the function f of x equals 2x plus 1, we would want to evaluate this function for multiple values of x so that we can plot those points on a graph. So we're going to start by learning to evaluate. When we evaluate a function for a given value, we plug that value in to the function for every x in the function. So we're going to plug in x equals 3 for every x in our f. So when we do that, we get f of 3 equals 2 times 3 plus 1. It is helpful usually to plug in with parentheses because sometimes we have negative numbers and that will affect our values. We have 2 times 3 plus 1. 2 times 3 is 6. So we have f of 3 equals 6 plus 1. So f of 3 equals 7. Let's try an example. So if we want to evaluate this function f of x equals negative x minus 1 for x equals negative 4, x equals 0, and x equals 3. So we'll start with f of negative 4. We plug in negative 4 for every x we see in our function f. So f of negative 4 is equal to negative negative 4 minus 1. See how it's helpful to keep parentheses around the value that we're plugging in? Here we know that negative negative 4 simplifies to positive 4. So we have 4 minus 1, which simplifies to 3. So f of negative 4 is equal to 3. Now we want to evaluate f for x equals 0. So we're going to plug in 0 everywhere we see an x. So f of 0 equals negative 0 minus 1. There's no such thing as negative 0, so it's just 0 minus 1. And that simplifies to negative 1. So f of 0 equals negative 1. See how nice it is to know which values go with what evaluation, right? When we have a lot of work on the page, now we're going to do f of 3, and we can see which each of them are because we have it in function notation versus y. If we had y equals for all of these, then we really have to look further to see what value we're using to plug in. So f of 3 equals negative 3 minus 1. Negative 3 minus 1 is equal to negative 4. So f of 3 equals negative 4. So we have evaluated our function f for the values x equals negative 4, 0, and 3. Now it's your turn to try. Evaluate this function f for x equals negative 2 and 2. Pause the video and try this example on your own. Hopefully you pause the video, and when you do, you get f of x equals negative 4x plus 7. When we plug in x equals negative 2, we get f of negative 2 equals negative 4 times negative 2 plus 7. Order of operations tells us that we need to multiply negative 4 times negative 2 first, which gives us positive 8. So we have 8 plus 7, which equals 15. So f of negative 2 equals 15. If we want to evaluate for f of 2, we plug in 2 for each of our values of x. So f of 2 equals negative 4 times 2 plus 7. Negative 4 times 2 equals negative 8, plus 7 equals negative 1. So f of 2 equals negative 1. Now we want to solve for the independent variable. So if we have a function h of x equals 2/3 x minus 5, and we want to solve for when h of x equals negative 7. Here, what we want to do is substitute our given value for h of x and solve for x. So we know that h of x equals negative 7, so we're going to plug in negative 7 for h of x. And now we're going to solve for x. So we add 5 to both sides. That gives us negative 2 equals 2/3 x. We multiply both sides by the reciprocal 3/2. Negative 2 times 3/2 simplifies to negative 3. So h of x, when it equals negative 7, our x value is negative 3. Now it's your turn to try. Pause the video and try finding j of x equals 1/3 x minus 2 for j of x equals negative 4. Solve for x. If you pause the video and you plugged in negative 4 for j of x, you got negative 4 equals 1/3 x minus 2. Adding 2 to both sides gives us negative 2 equals 1/3 x. And multiplying both sides by 3, we get negative 2 times 3 equals negative 6. So x equals negative 6 when j of x equals negative 4. Now, in the very first example, we evaluated the different functions for different values of x and got values of y. And we do this oftentimes in order to graph. So we can convert those statements to an ordered pair and use them to create a graph of a function. So if we have the value f of 0 equals 4, we want to convert that to an ordered pair. Here we know that x equals 0 and y equals 4. So when we plot that on the coordinate plane, we get the point 0, 4. If we have f of negative 1 equals negative 2, the x value of our point is negative 1, and the y value of our point is negative 2. So we can plot the point negative 1, negative 2. Now it's your turn to try. Convert these statements to ordered pairs and then plot them on the graph. Pause the video and try these two examples on your own. Hopefully you pause the video and we know that g of negative 5 equals 3 means that x equals negative 5 and y equals 3. When we plot that, we get the point negative 5, 3 on our graph. And g of 4 equals 3/2 or 1 1/2. Our x value is 4 and our y value is 3/2. And we can plot that point 4, 3/2 on our graph. Now we can use a graph in the opposite way. We can use the graph to find information about a given function. So we can use the graph to evaluate functions for different values of x, as well as to find x for a given value of f of x. So if we want to find f of 1 on the graph, we're looking for where the graph x equals 1. Where on the graph does x equal 1? We see that x equals 1 when y equals negative 1. So f of 1 is equal to negative 1. When we look for the value of 0, f of 0, we're looking where does the graph equal 0, x equals 0 on the graph. And we see that x equals 0, y equals negative 1. So f of 0 equals negative 1. And lastly, we can use the graph to find x for a given value of f of x. So if we have f of x equals 3, remember f of x means y. So we're looking at where on the graph does y equal 3, and what is the x value at that point? We see that y equals 3 here, which means the x value there is negative 3. So x equals negative 3 when y equals 3. Now it's your turn to try. So evaluate these functions using the graph, and then also find the requested value of x when f of x equals 2. Pause the video and try these on your own. Hopefully you paused the video and you found that at f of 2, y equals 0, and at f of 3, y equals -1. And when y equals 2, x equals -2. I hope you learned a little bit about function notation today. Thanks so much for mathing with me.